In this video, we will examine some questions and dissent raised in the wake of spreading awareness of our challenge and assertion regarding the sun and earthquakes. A surprisingly common and by far the most smile-producing of the comments has been, "I think this is fake." I'm not sure what people are thinking isn't real. The challenge isn't real. Is the science real? Is space weather news real? Oh God, am I real? Never mind. Let me introduce us. Space Weather News is the home of many informational websites and the Suspicious Observer's YouTube channel, the most watched space weather news program on the sphere, with thousands of the observers actively engaged in independent research and analyses. We founded the Mobile Observatory Project and the Observing the Frontier conferences, all of which can be dug into with more detail in the links provided below this video and at the end of it. The science is real. Our first two papers were peer-reviewed, and we've made two research updates to those at spaceweathernews.com/SPF. Co-authoring the foundational work was Dr. Kongpop Uyen, a NASA engineer who worked independently on this project out of kindness to the community, and the statistical analysis was led by Dr. Chris Holloman of The Ohio State University. The challenge itself, if you want to get a refresher, is at spaceweathernews.com/challenge, where both the beginner's version and the intermediate version of the video explanations of the science and the challenge can be found. The next most common question is about the numbers. The graphs do sort of paint one picture, and even those who dissent have trouble arguing that it at least appears there may be something to pursue here. But some of the math in our published work is a bit hard to follow, and perhaps you want something a bit more relatable. Well, let's start here. The average number of days between significant solar polar fields events was slightly above 110. It varied between 80 and just over 200. I like playing devil's advocate in favor of our dissenters, so I rounded down, and besides, 110 is easy math even for me. The most you could be away from either side of that 110-day window is 55 days, if you're right in the middle. No correlation between the solar polar fields and the largest quakes would mean that they were scattered across the timeline, fairly evenly distributed between 0 and 55 days from a significant solar polar fields event, with the average being about 27.5 days away. In reality, we're seeing that number nearly cut in half. The average of the largest quakes on the planet is only about 2 weeks away from a significant solar polar fields event, and that number itself is skewed by a few outliers at more than 60 days. If there is no correlation, we should see half the quakes more than 27.5 days from a significant solar polar fields event, but in reality, only 6% of the earthquakes were that far away. Even without a correlation, about 4 of the largest quakes should get lucky and be within a week of a significant solar polar fields event, and about 8 should get lucky enough to be within 2 weeks. In reality, 14 of the largest earthquakes were 7 days or less from the significant solar event, 20 of them within 10 days, and 22 within that 2-week window. More than 2/3 of the largest earthquakes fell into a window where only the luckiest 24% of the earthquakes should have fallen if there is no correlation. This is another way of looking at the data used to derive our p-value. This means we had a very, very small chance of error or randomness in the result. It is likely real. And before we hear a word from you on p-value problems, those have come largely from non-statisticians using statistics in their work in other fields. And when I raised these concerns to Dr. Holloman, he reminded me that he is indeed a statistics professor and that, shockingly, I was not informing him of a problem he did not know existed. I have forgotten more about p-values from that discussion than I knew walking in. The point is that this is not one of those situations, and everyone who has looked at his work since publication stands by the merit in pushing forward. And by the way, if you can remember what those numbers are supposed to look like, in 2015 and 2016 thus far, 80% of the quakes have hit within 11 days. We'd expect only 18% in that time. And half of the earthquakes were within 3 days, which would only be expected about 5 to 8% of the time with no correlation. Let's move on. A terrific question is, what is the mechanism by which these earthquakes might be triggered? Well, that's a big question, and about the only thing we're sure it's not is gravity. When looking at the interplanetary magnetic fields from coronal holes and the sun's poles, we're looking at fields that sweep out with the electric solar wind and touch the planets, extending past Pluto, and often connect with the planets for plasma interactions that are known as flux transfer events here on Earth. Beyond that, it's really anyone's guess, but what happens from sun to earth is a different story than what happens under the ground. We've seen magnetic field variations on earthquake days before, as well as ionospheric and GPS signals preceding the seismic tremors. There is an entire global electric circuit and geomagnetically induced current situation to consider as well. Right now, we can just see the pattern better than we can describe it. Our ancestors thought the sun was a living, jealous god, but they could still tell you when it would rise and set. Patterns and full explanations are two separate things. A prominent solar physicist has a big problem with our earthquake warnings based on coronal holes, saying that when there is a 6 magnitude earthquake on average every 3.5 days when you look on an annual time scale, you cannot issue 3-day earthquake watches because you will be right almost every time. First, we offer 48-hour warnings at most and usually keep it to 36 or 24 hours. And if you predicted at random, as he states, you would still not be right all the time, and here's why. What do these things have in common? The three situations I've set out here regarding earthquakes. Magnitude 6 every 3.5 days, 3 of them 1 day apart, and then 3 of them 1 week apart, 9 of them on 1 day, and then a month until the next one. They all have an average of about 3.5 days between earthquakes. However, the amplitude and wavelength of the fluctuation is by no means indicative of a 3.5-day cycle or any absolute cycle of this nature. And in fact, talking about a 3.5-day wait for a magnitude 6 earthquake may not at all represent reality. Let's just start looking at 2015. January began quiet with 6 days, and then 16 days of quiet, then 5. February began quick, then quiet for 9 days, and then a flurry of 3 in 3 days. They came in waves the rest of the month with 5 and 6 day breaks to end and enter March, which was back and forth until 4 of them hit in less than 9 hours near the end of the month, followed in April by some large jumps of 7 and 9 days. In the interest of time, we will skip to November where we see multi-quake days and 5 to 7 day gaps between them. I can go back to 2014 as well. It started fast, but then some big jumps without quakes. As you watch the rest of this, know that you can use the USGS archives to do this yourself, not just for every year, but just about every month. Months can have 2 or 3 large quakes, or more than a dozen. And the real bad science here is the delivery of an assertion that 3.5 days is an accurate way to look at the gap between magnitude 6 earthquakes. All the real variation in earthquakes was smoothed out and eliminated when he chose an annual timescale. Interestingly, he and I had extensive communication on this exact topic, and that one must consider latitude of a coronal hole, derived solar wind speed, polarity, etc. All of this was ignored in the public dissents made against our work after our communications. In fact, the coronal hole IMF presenting to Earth and the accompanying sector boundary magnetic changes can be tied to these weekly fluctuations in seismic activity that actually reflect reality. The larger magnitudes tend to be more common when the solar polar fields or derived solar wind speed indicates the IMF are strong in general, which is relative to ambient conditions and recent events, which accounts for the lack of major variability over the solar cycle. One comment suggested that this is not worth pursuing because solar activity does not target specific areas of Earth, and so the sun can't be used to predict earthquakes. First, there are other reasons this may be of value to science, especially since it sort of rewrites a portion of solar terrestrial physics. Second, the sun absolutely does target certain areas in different ways. The electrojets drive ground currents. L-shell compression drives electron precipitation and cloud deposition near the tropics and mid-latitudes, not to mention the L-shells actually move around and change in microtesla strength themselves. Global electric circuit effects are a potential bounty of correct answers, but the science involving space weather into the established paradigms there is just too new. The sun can tell us the time, and our other known pre-earthquake signals can tell us the location. The problem, as stated by Jeffrey Love, is that most of those signals could be caused by solar activity or other natural sources, so it is tough to discern what is a pre-earthquake signal, and we'd have too many false alarms for every actual hit. First, Who says the solar signal and the pre-earthquake signal are not the same? Our magnetic fields are connected, remember. But more importantly, if we know when the sun's timing the upticks, we can eliminate most of the false alarms. We'd still not be there yet. But are baby steps not okay? Do we need to make a leap to prophecy in a single bound? I hope not. Lastly, people want to know what I meant by saying I'd update the situation on July 31st. Simply put, we are expecting to be able to do little more than say whether or not love has responded at all. We've made the first move, and what we need next is an agreement to have an open mind and let us talk him through this for an afternoon. If you are a careful listener, you know that we aren't actually challenging love. He challenged the world, and we only challenge him to recognize that we think we've come closer than anyone else before, and that's not even including the time, location, and magnitude hits we had on Twitter in November of 2015, and that we've done about as much as he could ask for given a 4-week delay in data delivery to the public. Love made the challenge. After being ignored and insulted on the matter for the last year, we want to know if what we've done meets his challenge. Love himself has not made insults, but some of his colleagues have, along with others in the field who would be horrified if the sun actually caused earthquakes. Folks, there is only one thing to do here. Spread the word.